Hello and welcome to the second episode of Tech Nuggets and Thoughts. I am Nikhil Vanpal, your host, and today's topic of discussion is GitFlow. Now, before we get into the topic, I have an announcement to make. We have our own Twitter account. Yeah, it's Tech Nuggets, but without a U. So basically, TECH and GGETS. It's amazing. It's only the second episode, and we already have our own Twitter account. I mean, I know what you're thinking. It's free. We could have had it from the beginning itself. But you know what they say, right? Better late than never. So follow us on Twitter. Send in your suggestions, thoughts, recommendations, anything you would like us to have covered on this podcast. All right. So let's get started with today's topic. As I said, it's GitFlow. So before we talk about GitFlow, it is of course an expectation that you already know about Git. Git is a. I will just touch on what Git is. Git is an amazingly popular version control system, and it's highly powerful. So being popular, there's a lot of documentation about it, and being powerful, there's just a lot of chance that we'll shoot ourselves in the foot with it. So today's tool is one such thing that will save us from doing just that. One more thing that we should cover about Git is it's a distributed version control system. What that essentially means is that there's no central server hosted somewhere taking control of all your commits. So basically everything happens locally on your machine, and you send it to your coworkers or peers by sharing in a Git hosted somewhere. But the hosted version of Git and the version of Git that is running on your local laptop aren't much different. It's one and the same thing. Actually, your local can be converted into a shared server as well. So yes, that's the beauty of it. Now, being distributed brings with it a lot of you can say pains for people who are first timers. Things like a commit, it does not necessarily mean that the code or changes are available to other people. You specifically have to push your changes to other people so that they can, not just that, they also have to pull your changes to be able to work on your changes or make those changes available to them, right? So, but being local also gives a lot of strength, a lot of functionalities to Git. One such thing is branching. It makes branching very, very cheap. Branching is basically identifying a thread of development with a name. Technically, a branch for Git is just a pointer, nothing else. So all the commits, if you look internally how Git stores the commit, it basically creates objects and creates something called as a DAG, or directed acyclic graph. It just means that there's no commit pointing towards another commit which is in the higher up in the hierarchy or one of the parents. This ensures that all commits point towards their children and have a single pointer from their parents except for the merge commits. And there's no cycles in this, ensuring that the threads of development can be followed through from the root of the version control system or the first commit of the version control system till the latest commit. Every commit in this graph is actually identified by its SHA1 key, and a branch is simply a text file storing the ID of this SHA1 that the branch is said to be pointing to. So basically, this particular SHA1 is the commit identified by this SHA1 is said to be the head of this branch. And all the commits that are above this commit are parents of this commit, are part of this branch. Simple, right? So yes, but this is a powerful tool, because with this we can actually create individual threads of development. As in, I can group together commits or changes that are for a specific purpose. I can name them, I can identify them, I can always go back to them and find where a particular change came from, right? Any two branches in any given Git repository aren't exactly related to one another. Theoretically, you can actually have two different, completely independent projects on each of those branches, but that will be a waste of the abilities of this tool. Okay, we covered a lot more of Git than I had hoped for, but Git branch is something certainly of interest for us today. GitFlow, of course, is a Git branching model. You see, how you branch affects a lot of decisions in your development. Things like how you do your CI, how you do your CD, how your team interaction happens, how they share code, how your release management works. All of this is actually governed by how you branch in your Git repository. Like in most of the cases, there are multiple schools of thoughts about Git branching. Some believe that Git flow is not effective. They prefer another branching model, also called as a trunk-based branching model. Well, let's not go there. If time permits, we'll cover trunk-based branching models at the end of this episode. But let's come back to Git flow. So now Git flow is actually a multi-branch kind of branching model, and the beauty of it is that it works on the types of development or types of changes that we do in our code. So you'll find developers asking this question all the time, like, when should I create a new branch? Now Git flow takes away that question completely. It will automatically decide when a new branch should be created. Sounds intelligent, right? Well, it's pretty simple if you think of it like the type of change that you're doing. So one of the most common change is adding features to the product, and so every time you are adding a new feature, you should ideally be using a new branch. But where should you start this branch from? Should you start from the last release that you gave? Should you start from someone else's development? Should you start from a new feature that someone else was developing and just finished developing, or something like that? How do you decide that? So all of these questions are actually they actually go away if you have this Git flow in place. What Git flow says is that there are only two long-lived branches. Now, long is a relative term, so long-lived in this case means the entire life cycle of your product. These two branches should live, and no other branch should live that long is also equally true. Okay, so these two branches are one of them you already know. It's the master branch. It is your releases branch. Master is not where you develop, basically, and for doing developments there's another branch called a develop branch. Right, so most of your developments happen on the dev branch. When they are finalized, they'll be moved into a master branch and they'll be tagged. Okay, so we have two branches. One is master, one is dev. Now, when do you directly commit onto dev branch? When do you branch off from this branch is the next question that you would have, right? So that's where the feature branches come in. So every time you are creating a feature, you'll create a new branch, develop the feature on this branch, and once you are done, you'll move that feature into dev branch. So dev branch doesn't necessarily get unfinished features. It gets finished features basically after the branch merges into it. But of course, this dev branch can have bugs and a lot of critical issues as well. I mean, that's potentially possible. So now a feature branch always starts off from dev branch and merges back into dev branch. Another most important, or rather the most important type of change that we do in our product is bug fixes. Now, where do bug fixes start from? Now, this is not your unit test bug fixes. These are escaped bugs basically. So escaped, by that means an external or the dedicated testing team testing your code and identifying bugs, and these are the testing cycles that happen before release, not your integration or unit test bugs. Those should be fixed in your feature branch itself. I mean, you should be writing tests, right? And all of us do follow best practices, right? So we do write tests, right? So yes, we'll catch most of the bugs and fix them before we consider a feature finished, right? So yes, so now these bugs that we are referring to are pre-release testing cycle bugs. And they must be fixed before we consider a release ready for production, right? There are also some other changes like version bump and things like that should happen before your code is moved to production, right? Now, all these things are specific to a release, and all the release related things are supposed to happen on specific branches for the release called release branches. And okay, now we've covered 4 branches, right? One is master, one is dev, the other is all feature types of branches or feature type of changes, and the next we covered is the release type of changes, right? Now the other very important type of change that we have to do is hotfixes. Now all the process that we do, like we have unit integration testing, system testing, or whatever else we put in place, like end-to-end testing and manual testing, after all this we release something to production, and there are times when we still mess up, right? So yes, so to handle such scenarios, we have to provide a type of fix called hotfix. Now this is another type of change that we have to do in our code. So we have another type of handling for it called hotfix branches. Come to think of it, a hotfix always happens on a production code, right? So yes, so hotfix branch, if there was one, should start from the tag that was released to production. Okay, so now we have seen the major changes that we do with our code. Let's see what should happen when we make these changes. We've already seen that a feature branch should start from develop and be merged back into develop. Now a release branch, of course, should start from develop and be merged into master, our production branch. But that's not enough, because when we release something to production, we also should tag the commit with the version number that we released, right? So when we merge a release branch with master, we should tag the particular commit. But we've made changes on this release, right? They have to come back in the development, or we'll keep on creating regressions. So a release branch must be merged with dev branch as well. So release branch goes from dev to master and gets tagged and comes back to dev as well. Okay, the third type of branch that we saw was hotfix branches. So hotfix branch should start from a tag in master branch, have changes, merged back with master, have another tag with the new release that we gave to production, and any bug fix or any change that we did should be merged back with develop as well. So yes, okay, so many things to be done for every single change that we are doing, right? This is where Gitflow comes in. It says when to create a new branch based on the change that you are making to your code, right? But that was the original model that was proposed by we should refer to him as inventor Vincent Reason. I hope I'm pronouncing his name correctly. But as you know, of course, when there's something interesting that comes up, the community always lends a hand. Now, Gitflow doesn't really need a different type of tool, because it's basically a strategy for creating branches, right? What has happened is that people got together and created these scripts that group together these git commands into simpler shorthands to do all these activities in one go. Amazing, right? So instead of like saying git branch, create a branch name, and then switch to that branch, or merge the branch, create a tag, merge the branch into another branch, all of that automated completely based on the type of change that you're doing, and that's it. So there are keywords and there are automated handlings around those keywords, and that is what Gitflow scripts are today. And Gitflow is popular enough to be included in the default Git installation that comes for Windows, and it is pretty easy to install Gitflow scripts on most other operating systems like Linux or Mac OS as well. So once you have Gitflow scripts in place, all you have to do is like initialize the repository with Gitflow, because there are certain conventions. Now the Gitflow scripts don't really enforce the type of the names that you should use for your release branches or your development branches. It suggests basically with simple defaults, but you can override them. So when you say Gitflow init in a Git repository, it'll ask you some simple questions like what should be the name of your production releases branch. The default is master. What should be the name of your next release or regular development branch? The default is develop. You can choose to change them. I tend to change them to dev and master. And the next questions it has is like what would be the prefix for feature branches, the prefix for release branches and hotfix branches. It also has some additional branches which we did not cover because I've never really used them actually, the bug fix and support branches, although the options are there. Then another question is what would you like to use as a prefix for the tag that you would put in your master branch. So we tend to normally say that tag should identify the version number of the release, right? So when you're releasing, let's say version 1.1, the tag would be like v1.1. So you can choose to add v as your tag prefix if you prefer. So with this, your Gitflow is set up. Now there are very simple commands that you need to know. These commands are pretty intuitive based on the type of change that you would want to make, coupled with a set of standard keywords. They become almost obvious. And let's consider the pattern of this command. All the git flow commands of course start with git followed by the keyword flow, then followed by the type of change that you want to make, and followed by a certain action on that change. So action can be start, can be finish, can be publish, or list, or delete, and you basically get the hang of things, right? So let's consider a new feature development. So I'm starting a new feature called my amazing feature. So all I'm gonna do is like git flow feature, my amazing feature, and that's it. Git flow will now check out develop branch, create a new branch from it, check out the new branch. Perfect. Now when I'm done developing my feature, all I say is like git flow feature, my amazing feature, finish, and done. So the branch will be merged with develop and delete itself locally, and done. We can just now push develop branch and we're done. Now let's say if you wanted to collaborate code on a feature, so all we say is git flow feature, my amazing feature, publish, and gone. It's uploaded, it's pushed basically to the central repository, and others can follow the same pattern and say git flow feature, my amazing feature, pull, and it will be pulled down into their repositories. And if you want to list all the features that you're working on or are available in your repository, you say git flow feature name list, and it will list all the feature branches basically. Let's not talk about branches. Yes, all the features that you are working on. Simple enough, right? The same goes for releases. You say git flow release name start, and you start a new release. That's it. It's that easy and that straightforward. You know what is even more interesting? There are bash completion scripts even for git flow. So if you install a bash completion script, all you have to do is hit tab and it will show you all the possible commands that you can run after what you've already entered, just as git command line. Amazing, isn't it? Yeah, so that's about git flow. You'll get a hang of things when you actually work on it. I'm not, of course, going to cover each and every single feature from this amazing branching model that I've been using, but let's move on to what happens when you use git flow. The first thing you'll notice is a much cleaner and a standardized repository. When you look at your repository, you'll get to know what exactly is going on in which of the branches just by the name of it, right? That's one of the first changes. Secondly, now all your branches are in a following very specific patterns. You can use this to enforce user access controls on certain types of branches. So of course no one is allowed to touch the master branch directly, but your release manager has an access on it, right? Which also ensures that no one can, even if they wanted to, cannot mark things for production releases, right? The next thing is that it is very easy to set up multi-branch build pipelines, and because there are patterns and conventions, it is easy to set up what should happen in what type of branch. I of course, like in case of multi-branch builds, the scripts for build is actually checked in and is actually carried through all the repository in all the branches, but you still need common code in it, right? You don't want uncontrolled fragmentation of your build scripts. So what we used to do is basically identify the branch using the pattern and automate certain things like who all should be mailed when a build fails in this branch. For example, a build failure in a release branch is much more priority than a build failure in a feature branch. Maybe a build failure in a feature branch will send out an email only to those who are contributing to this feature, and a build failure in a release branch will be sent out to everyone on the team, right? Fire alert. Now I won't try to tell you that git flow will fix everything that is wrong with your repository. There are certain things that you need to be very careful about when you use git flow. Things like when you come to depend on the patterns of git flow, there's nothing in git or git flow that stops people from breaking the patterns, right? people can still manually create branches, random branches, and that can break your automation scripts at point. One of the other things that has caused problems for me in the past is when there are multiple people managing releases. You see, Git being distributed version control system, people have to manage synchronization manually, right? Uh, we faced problems when one of the release managers would release a particular version, and next time when if someone else comes up to release a version, they would still see the older release branch open in their local repository, right? And then Gitflow would complain, and that was a confusing state, right? So do we delete the branch manually? You basically have to prune the branches to keep in sync with the central repository, but that's something that you do have to keep up with. It's nothing specific to Gitflow as such, but a nuisance that we observed. Alright, I think we have covered everything that was there on the list for today's episode, and it's time to say goodbye. But before that, we have our own Twitter account now. It's Tech Nuggets, TECHNGGETS. Please feel free to reach out to me on this Twitter account or my personal Twitter account. I'm at the rate Nikhil Vanpal on Twitter. Please feel free to send in your thoughts and feedback. Also, by the time it is released, it is going to be 2018. So, very happy new year to all of you. Alright, with this, we've come to an end of the second episode, and I'll see you next time. Bye bye.